You know what you should do? Oh, I forgot. Alright, so, see how easy that was? Yeah. Alright, so 6 is greater than 3. Absolute value of 6 is also greater than the absolute value of negative 3. Absolute value of negative 1/4 is just positive 1/4. And the absolute value of negative 1/2 is positive 1/2. And we know that 1/2 is greater than 1/4, so that would go here. For here, we'd have the absolute value of negative 5 versus the absolute value of negative 3. And for absolute value, it's just distance from 0. So if absolute value negative 5, that is 5. Absolute value negative 3 is 3. 5 is greater than 3. So this is greater than that. So absolute value just means distance from 0. So whatever's inside of it, if it's negative, it becomes positive. If it's positive, it becomes negative for real numbers. So the last one, if we were to continue it, this is 5, and 5 is greater than 3. I'm now wondering if I regret using these because it looks like I'm saying greater than or equal to, and that's not what this is supposed to say. So let's just go like that.
And the 6 is like on the other problem just says 6.
What about the 6?
It's just come down like a 6.
Here? Yeah, absolute value of 6 is 6. The absolute value of negative 3 is 3. The absolute value is just distance from 0. Any questions? All right, here's a quick review on that. So now we plan on doing, yes?
Can I get a pencil?
I will get you a pencil, yes. Let's not do that, please. All right, so what we're going to do is we are going to go on to section 1.7, and we are going to plan on having a quiz as early as Thursday. And it's going to be on section 1.7. I think we should have another quiz before we do the test, and then we'll end up shooting for a test for the whole chapter 1 that we've covered. So, moving forward. This is your homework assignment that is due tomorrow. Go ahead and write it down. So here at the bottom, these are just the general forms of linear inequalities. These are all the possibilities you're going to have when we have a single variable linear inequality that's been reduced to these forms. So the question we're trying to answer today is, how do we solve single variable linear inequalities? That's what we're trying to answer. You can ignore what's circled in the orange for now. What you really need to take care of is writing down the homework assignment. This homework assignment is page 185, numbers 27 through 49, every other odd, which comes out to a total of 6 problems. So every other odd, 27, 31, 35, 39, etc. Yes? If we have time. Yeah, that's what we did. That's what we did last
Can you
time.
just keep going with the numbers? Because I'm
Wait,
It's every other odd.
I know.
Yes.
43 numbers.
What's the question?
What's the number that goes?
It's going to go all the way to, it may end at 47 or may end at 49, but it's every other odd.
You said every other odd.
Yes, that's what I said.
You're just trying to get low. You know I'm just gonna play with you.
How does that your best view? You just make notes.
How is it on
You
my
got third notes?
How is it on my desk?
You got third notes?
All right, here we go.
Wait, hold on,
All right now, okay. You don't really have to worry about what's in orange here. That's just, again, that's just a general form for linear inequalities, single variable. Alrighty, moving on. So let's cover some basic union, intersect, set notation kind of things here. So if I define A to be a set, and this is like the first part before the part we're going to look at, I don't want to spend too much time on it because it becomes included in what we're going to do, and it's very, I think, fairly simple, especially for you guys and where you're coming from. If I have A is this set, to say it contains these specific set of values, 1, 3, 5, 7, 11, 19, and B is specifically this set, 3, 11, 13, and 26, A union B here is going to be combining all of the elements. And we don't need to write them twice. We don't need to repeat. So I know this guy, they both have 11. I don't need to write 11 twice.
I'm sorry. I have a question.
Yes.
You said 27 and 49, but you said 6 of them. And
Yeah.
it goes to 47.
Okay.
Do we do 49?
No, just stop wherever it doesn't, wherever it hits. Yeah. You can if you want. You don't have to. Yes.
All right, so the U and that, over, I forgot what they used to use. I went on the
Okay.
things.
So that's where, yeah, good, that's where we are. So this means A union B. This means go ahead and combine all the elements from each set. Put them into one set. Okay. So if you look, we combine all these, you would have this set here. And there's no need to repeat the 3. There's no need to repeat the 11. It's understood to be part of it.
And the second one is the constant down common.
And yes, now the second one here, this upside down looking U, this means intersect. This means what they have in common, what they only overlap. And if you notice that their set is just going to be 3, 11, because they only have 3 and 11 in common. All right.
Really? Does that say union?
Yep, that means union, and the upside down one means intersect. Now,
I'm over to talk to you myself. I'm hungry.
okay.
So the second one, oh, I see.
Do you have a pass?
No.
It's the same.
It's our
One
own.
value is what's the same as the other one. It's just like,
All right, here we go. So, how to solve linear inequalities? Try to ignore this thing here. So, this is on page 176. What we're dealing with, and I want you to realize that we solve these guys. Norman, Maya, please quit talking. Put you up if you keep talking. So you want to solve just like an equation, except there's one rule. That you must flip the inequality sign when multiplying or dividing each side by a negative value.
Does it say except for one?
Yeah. So there's one rule. You must flip the inequality sign when multiplying or dividing each side by a negative value.
Don't switch it yet.
It says equal side by negative.
You sound like.
You must flip the inequality sign when multiplying or dividing each side by a negative value. Yes. Alright, that's the golden rule.
Wait,
Yes.
when you say solve is like an equation except for one rule, like,
Yeah.
do you mean like it's skipping a step and then it's going to lead to something else, or do you mean like you're doing the same thing, but something changes?
You're going to treat these just like if you solved an equation that was, let's say, that was a single variable linear equation you want to solve for x. You do everything like you have been doing, except there's just one rule you have to remember. In case this comes up, if you divide both sides by a negative, you have to flip the inequality sign. That's the only thing. Otherwise, you treat it just like you would solving an equation.
Okay, thank you.
Mm-hmm. You want any more time?
Yeah.
So we're discussing on page 176 how to solve linear inequalities, section 1.7. This will be available to you, of course, at the end of the school day in that PDF format on Blackboard and also the video. All right, so let's look at an example here. We have something like this, if it decides to cooperate. Okay. So we have something like this, 0.2x plus 125 is less than or equal to 335. This is on page 176. And we're looking to solve for x. So just like if this were an equation, the first step you would do is subtract each side by 125. Actually, I'll let you guys go ahead and work this out. Let me know what you get.
What is this called?
This is a single variable inequality. Okay. All right, awesome. All right, so what do we get? I heard one correct response thus far. Okay, so what's the whole thing though? Say the whole thing.
0.2
What's 1,050? Is x less than or equal to 1,050? Is it greater than or equal to? Okay, x is less than or equal to 1,050. Very good. Good job. All right, so you're just making sure your skills are on par. So subtract each side by 125.
It's just like the thing in
Why do I have to write the less than? It's there instead of.
This is not an equation. This is inequality.
Okay.
All right, and then the last step, yes.
So the x is everything from the arrow.
Yeah, the x says that x is less than or equal to 1,050. So if you were to graph this, which you need to know how to do on a number line, you would put a dot, a filled-in dot above 1,050, and point it to the left because x is less than or equal to 1,000.
Some of it is positive. I'll say negative.
Okay, so we'll discuss the number notation in a second.
Is it because?
We'll discuss that in a second. I need to make sure everyone's okay with this so far. Do you have any questions thus far? Please feel free and ask.
I think I forgot how to do this, Mr.
You guys are very talkative. You don't need to make comments like all the time. If you have a question or something, you can ask. But other people are a little more quiet. It just gets to be too much sometimes. That's all. It's okay. I want you to ask questions, but just not blurt them out. Or every time you see a line, you say, "Oh, whoa, what? What?" Just focus, breathe. You'll get it. If you still understand something after you looked at it for more than a few seconds, go ahead and raise your hand. I want to help you. Okay, so last step, divide by 0.2. You should write here, and this is how you would graph it. You would need to have a number line. You don't need to plot all three values that I have. I just decided to throw in three values. I put it, definitely need to have 1,050 here. And then because it's less than or equal to, if you write it like this, the way this points, that tells you which direction to write it. And it's a filled in circle because it's less than or equal to. If it were just less than, it would be an open circle.
So, okay. We can make our own number line?
Yep, just make one up. Yep. And then, again, let's not do that. Interval notation. So the interval notation is from -3 to 1,050. So why is this? Because x is less than or equal to 1,050, there's no restriction as to how small x can be.
But it only goes up to 1,050.
But it only goes up to 1,050, which is why on the right-hand side here for this part of our interval notation, we have a bracket. It says, okay, go that far, but include 1,050. Yeah. Yeah, so this is as far as it can go to the right, but it can go forever going towards negative infinity.
So the bracket is like a restriction?
The bracket says make sure to include this value 1050. Okay, because it's less than or equal to.
Okay.
Because it's less than or equal to. If it was just less than, it would be a parentheses. Yes.
What if it was the opposite? What if the thing was, what if it said it's greater than or equal to?
Greater than or equal to, then this arrow would still have a dot above 1050 and it would point to the right. And then over here we have a bracket 1050 comma infinity parentheses.
The bracket will never be on the infinity.
Correct. Yes. Because infinity is not a value. It's not a value. It's not something you can contain. It's an idea of going on forever.
I have a question.
Yes.
What's like our answer? Like on
Okay.
question
So let's
something
say
all three
let's say
different-
the directions are to solve for x.
Oh.
You could just write this and be done. If the direction said solve for x and graph or plot on a number line, it would be this whole thing here, this and this. If it said solve for x and write your solutions in interval notation, you have to include this interval notation. So let's be familiar with every aspect of it.
And then the dot, isn't it like, I know you're talking about it, but I don't understand. Is it clear when there isn't an equal?
Right, when it doesn't have the equality part of it, if it's just, let's say, less than, it would be an open circle. We're going to see another example, yes.
Why do you put the negative infinity?
I put negative infinity because there's no value that x can't be if I start going towards the negatives and go on forever and ever. X could be, for example, negative a million, negative a billion, negative a trillion. It can go on forever and ever going towards the negatives because x just has to be less than or equal to 1050.
Alright.
And so it's capped off at 1050. Guys, right? Yes. I'll be there in a second. Let me get started on this phone. So let's go ahead and take a look at this guy here. Go ahead and see what you guys get.
Make sure I'm doing this right.
Yes. Okay, we're going to go over it together. All right, here we go. So there's more than one way to solve this. Okay, you can decide to start off, hey, I'm gonna add 2x to both sides, or you could say, well, I'm gonna subtract x from both sides. Whatever you want to do, just remember that one rule about divide and multiply both sides by a negative. You gotta flip the inequality sign. So let's see what happens here. I happen to pick the path of subtracting x from both sides. Doing so would give me this value right here, this new inequality. Negative 3x minus 4 is greater than 5.
Wait, so if I multiply by a negative or divide by a negative, I have to find it.
Yep. Anytime you multiply or divide by negative on each side, you have to flip the sign. So let's keep going. I went ahead and add 4 to each side. So now I've isolated, so it's negative 3x is greater than 9. And then now the last step is to divide both sides by negative 3, so I just solve for x. And x would be less than negative 3. Notice that the sign has been flipped because in the last step, I divided each side by a negative, so I had to flip the sign.
Wait, can you say that again? Can you say that again?
I had to flip the sign on the last step because I divided both sides by a negative value.
Oh, okay.
If it was like a positive, you want to split sign.
So if this said, for example, this line here said, this line 3x is greater than 9,
Yeah.
and I would just divide both sides by 3, and it would not flip because I'm not multiplying or dividing by a negative. Yes.
Do I have to put an equal sign at the bottom? And I,
Put an equal sign?
yeah, like greater than or equal to or no?
No, this sign, it does not have an equality part to it. It's just x is less than negative 3.
Does the same thing apply if it did have an equal sign to it, or do I have to flip the thing?
Yeah, so no matter what, good, no matter whether it's just the less than or greater than, or less than or equal to, greater than or equal to, whether it contains that equality part or not, you flip it, no matter what the sign is. Good question. And so, knowing how to plot it on a number line, and notice it's an open circle above negative 3. Because, yeah, there's no equality part to it, so it's just less than, so it can't actually be negative 3. You know, it can be negative 3.00001, but it can't be -3, yes.
So that's why you have the parentheses saying that it can't be negative.
Exactly, and that's why this is parentheses, not a bracket. A bracket says including this value, but we're not including -3 because x must be less than -3.
So,
Yes.
What's the difference between parentheses and brackets?
So a bracket tells us that it includes a value. Like, for example, if I were to say, let's just do an example off to the side here, we'll do it in brown. If I have some simple example like x is less than or equal to -3, then we would have all the way to -infinity. But at -3, because it can be -3, we have a bracket. Bracket says including this value -3. This says all the way up to, but not at -3.
Okay, all right. So like -2 times.
No, it could be -3.001. It can't go any greater than, can't be at -3 or greater. -2.9 would be greater than -3. So if you look at here, you see that can't go.
Oh, yeah, that's.
Yes.
So when it has a bracket, when it has the underline up under the greater, and it's greater to the or equal to, then we know it's a bracket.
Yep. If it's greater than equal to or less than equal to, there's a bracket that's going to be involved.
Okay.
Good.
And how do you know if it's like -3? Like how do you flip?
How do I know when to flip?
Oh no, like the parentheses. What's the thing in the parentheses? How do you know when that's on the other side?
How do I know whether it's -3 or -3 is -infinity? Well, you have to think logically here that x must be less than -3. So x, for example, could be -5,000, -1,000,000. So going in this direction on the left one here, this guy right here, this is talking about like the restriction going towards -infinity. Well, there is no restriction. It could be whatever small value wants to be. Can't speak my glasses. Yeah. Your head up. But going to the right, it must be less than -3. So the maximum it could be is really close to -3, but it can't actually be -3. So we need a parenthesis. Any more questions about this? Or move on to the problem? We're trying to get there.
I was just like, forget that, let's just go to
Okay. So,
6 problems.
example 5. Knowing how to solve this inequality when you have some fractions involved.
Multiply both sides.
Yeah, so this is just like we've been solving them. Just the one idea here is that we typically don't like dealing with fractions if we don't have to. So we're going to go ahead and we're going to limit the fractions immediately right off the get-go. So, yes.
Can I get another pencil?
Another pencil? Sure.
So needy.
Oh.
Don't look at it.
There's also this is sharpener in the back.
If I multiply the 4, do I have to multiply it to the 3 too? If I multiply the 4, like times 4 to get rid of that.
You don't multiply the 4. Unless you're thinking about on this side, if I multiply something by the something with the 4, I have to also multiply to the top. But that's not quite what we want to do.
It's not like multiplying and then go to the other side and cross out.
Sort of, we'll see. So here's the idea. I want to get rid of fractions, right? So I think we all agree that we don't like dealing with fractions, we don't have to. So what is the least common denominator of each of these? It is 12, right? When I say least common denominator, that's the least common multiple of all these guys.
So what's the 3?
3 is not the least common multiple.
Oh, least common multiple. 12.
Would be 12, yeah. Easy way to do it is look at the larger guy, because it has to work for all of them. So let's say we had 3 different values, especially, I'll start with the largest and go through its multiples until I find one that works for all 3. Of course, the product of all 3 will immediately work. Yes.
What if it doesn't like, what what if the denominators, they don't all like have a common
They will all have a common denominator, even if it's the product of all three, if you have to.
Oh, okay.
Product will definitely cover them all. All right, so then we agree that that is going to be 12. So what we do, we say okay, because the blue is the original. So we're going to multiply both sides by 12. And what happens when we do that? Well, I went ahead and worked it out in detail. Some of you may do it more quickly than this, but I just went ahead and was very detailed. When you multiply by 12, that's the same thing as multiplying by 12 over 1. So same thing over here. I went ahead and distributed the 12 over 1 to each part.
Wait, why did we cross it out?
So before looking at the red, just understand that I'm multiplying both sides by 12. I'm distributing this 12 to each term. And I'm writing it as a fraction because I know that when I multiply fractions, I'm allowed to simplify diagonally or directly up and down.
Yeah.
So now I can look at the red and say, okay, how did I simplify this? Well, the 12 and the 4, they both have 4 in common, so I divided the top and the bottom by 4.
So you made the bottom all equal to 1, that's smart.
Yeah, the bottom, the product is going to be 1.
And
That was the whole idea.
cancel that out.
Yeah, that was the whole idea, was to get rid of fractions. So then 12 divided by 4 is 3, and 4 divided by 4 is 1, so that becomes 3, becomes a 1. This guy becomes a 4, becomes a 1. This guy becomes 3, becomes a 1.
Why is that one, the far one?
This here,
Yeah, why is that one becoming a 3 and not 4?
because you have 12 and 4, and the greatest common factor of 12 and 4 is 4. 4 divided by 4 is 1, and 12 divided by 4 is 3.
Do you distribute?
Yeah, I distributed. Notice that to 12 times this guy.
No. After that step.
All right, hold on. Hold on. I want to make sure. Any questions up to this point? Okay, so now the next thing is to just write it more simply put, like this, where I have, okay, this is 1 times 1 is 1, so now I just have 3 times x plus 3. I could have wrote over 1, but not necessary. This is the main idea behind me doing multiplication of 12 on each side, was to get rid of the fraction. You notice it does. Here, if I went straight across, 4 times, be very careful, parentheses x minus 2 over 1, which is just 4 times x minus 2, and then finally this guy just becomes 3. When you multiply fractions, we just go straight across.
Wait,
Actually, you can combine those two. The 4 and 3. Can you do that?
oh, I see, first, never mind.
Any questions where we are right now? Yes.
For the next step,
Any questions? That's fine. I like that. Any questions where we are now, though? I want to make sure everyone's good. Yes, go ahead now.
for the next step, like you said, would you add the 3 and 4 and then multiply into the x minus 2?
Yeah, I can't add 3 and 4 because the 4 is connected with multiplication with this binomial here. So now there's no real advantage for the way it's written. I have to distribute the 3 and distribute the 4, and you'd arrive here.
Always kind of that.
And I'll let you guys finish this one up and let me know what you get.
Where did,
Yes. Yes. Does anyone have any questions?
Wait, don't move on yet.
Or maybe they're stuck? Okay. Take a little bit more time. Yes.
because I don't want to say that.
All right, here we go. So,
Yeah, I got
distribution, simplifying like you had stated, combine the negative 8 and 3. And then,
Why did that flip?
hold on, let's get to the first step there.
I was thinking about that. I don't know if that worked.
So then we have this here. I did it all in one step. I went ahead and I got rid of the x's on one side and then got rid of the constants on the other. If you need to do it step by step, please, of course, do that. Be careful. But there's no problem with adding, subtracting different elements. As long as you do it to both sides, you're fine. Just addition and subtraction. So then you end up at 14 is greater than or equal to x. If I want to write an x and the rest, the remaining, I would have to flip it because 14 is greater than or equal to x, the same statement as x is less than or equal to 14. So it needs to be pointing the same direction. We'll flip it around I'm really flipping these two around
It's the same
this
thing.
guy. Is really what I'm doing.
Why can't
I flipped it like this because it's more common to leave the inequality as variable and the rest. I'm perfectly fine accepting this as an answer. Just don't then make a mistake when if you have to end up graphing on a number line or interval notation. It's just probably a little bit
you
safer.
switch it, like when you're dividing by negative, like what about multiplying by
Yeah, so I didn't switch this because of multiplication by negative. I just switched it because 14 is greater than or equal to x is the same statement as if I want the x on the other side. Just imagine doing this whole thing here and just doing this. That x is less than or equal to 14.
I'm just asking if it multiplies by negative, you switch it. I don't know, like, I'm not talking about this problem.
Yeah, so anytime you multiply or divide both sides of the inequality by a negative value, you have to flip the inequality. Simple sign, yeah? Yes? I don't know. Good question. Someone's using that.
It would be different if it was like negative 14 and then you would flip the x and then after that.
So let's do an example. It's a good question. So we have, if I had example, and this has nothing to do with this, if I had negative 14 is greater than or equal to x like that.
Yeah, then you would flip it first.
Okay. So I say I divide both sides by negative 1. Then I would say 14 is less than or equal to x. And then if I want to read x first, I just go around like this and say x is greater than or equal to 14.
Okay, so you're just
Good question.
flipping the middle part, and then if you want to flip the x around, then you flip the entire.
Yes. And I'm fine if you leave your inequality like this, you'll get full credit. Just avoid making a simple mistake.
Yeah.
All right, so I wrote it like this because this is common. And then, so now from here, just drafting this, x is less than or equal to 14. So I'm going to fill in the circle above 14 because it can be 14, and then everything less than that it can be. So we draw the arrow going to the left.
So x is basically where the arrow is going.
Yep, when it's written like this, you can see that the inequality is pointing that direction. That's easier to read. Okay, it points that way. So I
Wait,
do that.
Mr. Brookie.
Yes.
On that example, what happened?
On this example, we just have an example of negative 14 is greater than or equal to x. I multiplied both sides by negative 1, so I had to flip the sign. Well, I'm confused too.
Yeah, wouldn't the
I'm
x be
sorry.
negative?
See, this is a long day. I'm glad you pointed that out. So, thank you so much. So, there was no real need to divide both sides by negative 1 because I already had x isolated. So I could just flip it around and say x is less than or equal to negative 14. Thank you for that correction.
I was
Much
actually
appreciated.
thinking the x would be negative.
Yeah, don't do unnecessary work. And then the interval. Any questions on the interval notation? Okay. Okay, so then you have, this is one of the homework problems.
Oh, yeah.
Page 185, number 43.
Solving for x.
Solving for x, yep. So I can walk you guys through this one.
Page 180. Oh, what's up?
If we wanted to solve this, there's more than one way to solve it. If you want to subtract 1 from each side, you can do that. If you want to get rid of fractions immediately, you can go ahead and do that. And that's actually what I did. I noticed the least common denominator is 2. So I multiply both sides by 2. And you arrive here. 2 minus x is greater than 8.
Oh, if I subtract the 1, that would be 3.
That's correct.
And then if I multiply both sides by 2, that would be 6.
We have negative x is greater than 6. That's correct. Yeah.
I'm still on the right path though?
Yep, as long as you're careful. And then now continuing this path here, I went ahead and subtracted 2 from each side. So negative x is greater than 6.
Put the negative on the other side, switch the sign.
And then multiply or divide both sides by -1, you would have to flip it and say x is less than -6. Yeah.
Did you just say multiply both sides by -1?
Yep.
Divide.
Multiply or divide, it doesn't matter.
What, the -6 and the 6?
Yep, I have to multiply both sides by -1. When doing that, it flips it. So x is less than -6. Here it is graphed on a number line, and here it is in interval notation.
So what are the problems?
You need the homework. You need the homework. Do you need the homework assignment? Go ahead and ask one of your neighbors, please. Yes.
Yeah, what's the handle with the light?
What's the what?
The
Math.
capital N?